Now, the last part that we're going to cover is our order of operations. So there are various different acronyms that have been taught depending on where you're from, on how to solve through order of operations, but it follows this basic three-step premise. We always want to take care of grouping symbols, such as parentheses or brackets. A fraction bar can create a grouping symbol. We want to evaluate the numerator and the denominator separately. And we always start from the innermost set and work our way out. And within fraction bars, we want to evaluate other sorts of grouping things, such as exponential expressions, roots, and absolute value. And we'll take care of those in order from left to right. Once all of those are taken care of, we go through multiplication or division, whichever shows up first in order from left to right. And then we end with addition, subtraction, same thing again from left to right. So here we only have operations of division and multiplication. And so we can go ahead and move to step 2, and we go from left to right. So we want to take care of our first operation of 20 divided by 2, which is 10, and then we can multiply by 10 to get 100. Here we have a grouping symbol, so we need to take care of what's inside the grouping symbol first. 1 plus 2 times negative 3 squared. Now that we've taken care of the grouping symbol, we can go ahead and move on to the exponent. We can evaluate the exponential expression. Negative 3 squared. So we get 1 plus 2 times 9. Now we can move on to multiply. 1 plus 18. And then we end with addition. We have some grouping symbols within the numerator and the denominator. We can take care of these and assume these as a group. We have to evaluate our absolute value first before we do the exponent. We can also evaluate our square root that's in the denominator to save ourselves a little bit of time. So the absolute value of negative 2 is 2, and then we will cube that over negative 7 minus the square root of 4, which is 2. Then we can move on to the exponents. We end up with 2 cubed is 8 plus 1 over negative 7 minus 2. Now we can take care of our addition and subtraction within the numerator and denominator. 8 plus 1 is 9. And then negative 7 minus 2 is negative 9. And then we can finish with our division. 9 divided by negative 9 is negative 1. Here we want to work from the inside out. So these are our innermost groupings. We want to take care of those subtractions. 3. And then our bracket, so 4 minus 6 is negative 2. Plus 2 times 5 minus 9, which is negative 4. Then we can do our multiplication. That's inside of this larger bracket. So I'm just writing down everything else. And then we're adding negative 8. I use that parentheses to kind of separate it from the operation. Now we can go through and evaluate this set of brackets, 3 minus negative 10, and then we can end with the subtraction of 13. This last one has a lot of steps to it, so let's just take it piece by piece. So within this radical, we have this grouping that we need to take care of. We can also simplify the expression within our absolute value. So negative 5 times the square root, 30 minus 5 is 25, plus, and we can actually save ourselves a little bit of time by going ahead and doing this group as well with the exponent, which gives us 4. All of this will be over. We can take care of the next exponent here at 16. Plus the absolute value of negative 3. Then we'll go ahead and simplify the root and the absolute value. Negative 5 times 5 plus 4 over 16 plus 3. Then we'll go through and take care of our multiplication. We can go ahead and actually do this since it doesn't have any other operations in that group. We can simplify it in the same step, save ourselves a little bit of time. Negative 25 plus 4 over 19. And then we'll do our next addition in the numerator to give us negative 21 over 19. And since we don't have any other operations besides simplifying the fraction, and it doesn't make our lives any easier, we can go ahead and just leave it as negative 21 over 19. Last thing we'll cover is evaluating expressions. We've done a little bit of this before, but we'll go ahead and kind of take it another step forward by using our order of operations as well. So evaluate each expression when x equals 4 and y equals negative 3. So anytime we see an x, we replace it with a 4. Anytime we see a y, we replace it with a negative 3. So we'll take 3 times 4. Actually, let me do that in red so we'll match the marking up ahead. 3 times 4 minus 7 times negative 3. And we can use our order of operations to simplify. Multiplication first, 12 minus negative 21. And then we take care of our addition. Remember, that's adding the opposite, so we end up with 33. For b, we actually don't have an x term, so we only need to substitute in the y. Negative 2 times negative 3 squared. We evaluate our exponent first. Negative 2 times 9, and then multiply. And this last one, we can go ahead and plug everything in. So for our x values, we have the square root of 4 and a 4 down here. And for our y values, we have a negative 3 and a negative 3. We'll simplify the radical first. So we end up with 2 over negative 3. And since we have minus a negative, we can actually just change that to plus. And then we want to make sure that we get a common denominator, which in this case will be 12. So in order to get a denominator of 12, and using our fraction equivalency, we can move this negative up front. So denominator of 12 for both of these. And we'll have a numerator, if we multiply by 4, of 8. And we multiply by 3, we get 9. So we'll have negative 8 twelfths plus 9 twelfths, which will give us just a positive 12. And our last one here, we want to evaluate 2 times x sub 1 minus x sub 2. This is called a subscript. And with subscripts, it's important to note that it's just differentiating between two variables that happen to be the same, but they're going to be represented by something different. There's no operation that's done with x sub 1 and x sub 2. So x sub 1 equals negative 5, while x sub 2 equals 7. So we just substitute these in. 2 times negative 5 minus 7. We follow through our order of operations, and we evaluate our expression.